So, good day, guys. How are you guys doing? I trust you guys are doing wonderfully well. So, in today's lesson, we'll be looking into physics, big units, and dimensions. So, you guys already know what unit means and dimension also. But let's just say something. Dimension is kind of is a dimension is that. For instance, in this case, we have fundamental and derived units actually. Dimensions deals with the fundamental units, the first three letters of fundamental units. Are you getting it? So that's what dimension focuses itself on. The first three letters of fundamental unit, that's length, mass, and what? Time. Do you understand it? So having understood that, that's length, mass, and time. Right? That's it. Like when you say mass, length, and time, let's use this one and this. It's simply just the arrangement that you've had. Do you understand it? So it's mass, length, and time. Those are the first three fundamental units. You have seven of them. That's length, mass, time, electric currents, and to be many of them, amount of substance, luminous intensity, there are electric currents. But these are the first three, and these are what we use in dimension analysis. Do you understand it now? So, nevertheless, now in dimension, what is the aim of dimension analysis? Now, dimension analysis must have let me use three forms that it can be expressed in, that it can be used. Now, firstly, that's method of dimension. These are the methods of the analysis. Now, firstly, what is the method? Now, one, dimension analysis helps you to know the exact form of the physical quantity. Two, it helps you to know the correct units of the quantity. Do you understand it? And lastly, it helps in verifying the correctness of a physical equation or relation. These are the three methods of dimension analysis. Now, let's explain them this way. Firstly, it's used in checking verifying the correctness of the physical relation. Secondly, okay, let's start here. It's used to know the exact or the units of a physical quantity. Now, for instance, the dimension analysis. Now, you have to know this. All the fundamental quantities, we don't need, they have nothing to do with dimension analysis minus this, only this length, mass, and time. Dimension analysis deals solely on derived quantities. Do you understand? For instance, force. Force. Force is mass and its acceleration. And the derived quantity. Right? Yes. Now, you can get the units of the force using dimension analysis. Now, mass is what? Mass is what? Now, let's say we're using these two words, we're using this MLT, mass, length, and what? Time. Mass is really M. So, need of changing this down to M times acceleration, that's change in velocity over time. That's change in velocity over time. Right? And velocity itself is what? Velocity. You see, velocity itself is just LT minus 1. How? Velocity is distance over time, right? Yes, velocity is distance over time. And distance is length, right? Yes, we are doing on that. And this is time. So when you take it up, it's same as writing LT power minus 1. Do you understand it? Are you getting it? So that was how this came Change the velocity is still LT minus 1 over time. Now, this time, when you take it off, LT minus 1, add the dots, bring this thing up. If you take it off, remember this is bearing a positive sign here, a positive one here. When you take it off, it now have a negative one. Do you understand it now? And you have this minus 1 times minus 1 and minus 1. Now, this is times, right? Yes. Remember, law of indices that state that when two b's, it will be a dot a and half power of 4 and 2. Since there are two bases multiplying each other, collect one of the b's and add the powers. Right? Yes. So here, that's what happened here now. Now, minus 1 plus minus 1 is what? Minus 2. Good now. Now, we have gotten our ascension to LT minus 2. So this velocity is LT minus 1, ascension is what? LT minus 2. Do you understand it now? Then, put this in LT minus 2. So we are gotten this force to what? LT minus 2. So this is force. Now, how can you get the units for this? Now, M is mass. It is what? Kilogram. M is what? Length. Unit of length is what? Meter. T is time. Unit of time is what? Seconds. Add this. So kilogram meter per second square. That's the unit of what? Force. Do you get it now? So that's just it. Now, the second way. Now we have proven our point that dimension can be used to get the units of a physical quantity. That's just it now. Now the second one, dimension analysis can be used now to verify the correctness of a physical relation or equation. For instance, we have this S is equal to what? Distance 50 plus what? Half 80 sphere. Now, how can you verify the correctness of this physical relation now? S is distance, and distance is just what? M. Right? Yes. U is what? Initial velocity. And velocity is what? LT minus 1, as we got earlier. Then we have T. This is time, right? We have T. Plus, we are trying to check whether we have this, or the aim now is so that this, and this will be the same form. Now, half 1 over 2 is a dimensionless quantity, so we don't need it. A acceleration, as we put our acceleration to the what? LT minus 2, and we have this time to the what? 2, and it's a plus, right? Plus. The other and the 1 plus 1 here. This is plus 2. Now, going further, L is equal to, you have this L. T now, there are two forms, right? Take one of the T. Minus 1 plus 1 plus, take one L. T minus 2 plus 2. You have 2T, took 1 and added the powers. Now, L is equal to, now L minus 1 plus 1 is what? 0. So I'm using that this is already out. And L times power 0 is what? 1. This L times 1 is still what? L. Same thing goes here. L minus 2 plus 2 is what? 0. L times power 0 is what? 1. So this will have L, and L, length. So this proves to us that this is actually what's correct. That dimension analysis can be used to get the exact form of physical words to verify the correctness of a physical words relation. And this word just did not and got this. Do you understand? Then, lastly, there are given two applications. Remember one more. We say that it's used to get the units, verify the correctness of the principal words and relation, and lastly, it is used to get the exact form. Now, for instance, the okay, just note that know it very well, actually. I can't say that it's too long. I don't have that time actually. But I will still put it in one of my videos so you guys can learn it. Do you understand? Are we guys okay with that? So now let's get units of dimension analysis now. Units of physical relations now or quantities. Now, what is dimension analysis of viscosity? Viscosity is force over area times the velocity gradient. This is viscosity. Remember, earlier we got our force to be what? MLT minus 2. And area is what? L squared. Right? Area is length times this now, length, L squared. Length times breadth, bro. Yeah, we call all them length. You see, displacement, distance, length, breadth, height, they are all length. Like their dimension is just what L length. Do you understand it now? So, then velocity, let me use the dot rather. Velocity is LT minus 1. And velocity gradient is LT minus 1 all over what? L. This is velocity gradient. This is how to be represented. And in this case, you can just take this and take this. You have MLT minus 2 divided by what? L squared dot what? T times 1. Let's take this up. Now look like this. MLT minus 2 dot L. Now this is your positive form here. When it goes up, inverse of positive is what? Negative. Now you got minus 2 dot. This is a negative. If it goes up is what? Positive. Dot what? T1. I get it now. Now you have this. The M is on this one. The M has nothing to do with other quantities here. Let's take it out because it's on this one. L, you have one L, you have two L. L, here is the positive one. And this one, you have L and L. You take one of the L, one of the base, L. And let's deal with the powers. Plus 1 and minus 2. Plus 1 minus 2, right? And then we work on T. Plus 2 minus 1. Minus 2 plus 1. This is in plus positive form. Minus 2 plus 1, right? This is now M. L. Plus 1 minus 2 is what? Minus 1. And for T, minus 2 plus 1 is what? Minus 1. So this is dimension analysis of what? Viscosity. And if you want to get to unit, the unit of viscosity is what? Kilogram per meter per what? Second. So this is it. Is it clear to us now? So this is how we find other dimensional analysis of every other quantity. Do you get it? If you want to learn something new today, see my next video and bye for now.